Okay, in this video we're going to talk about the rules of exponents and do a bunch of examples. So the first thing we got to do is we got to know all of the rules. So first rule is if we have the same base and we're multiplying, so we have x to the a times x to the b, what you're going to end up doing is adding the exponent, so that's x to the a plus b. A second rule that's similar is if we have the same base but we're dividing, so x to the a over x to the b, the net result of that is going to be the base, which is x, to the a minus b. So multiplication becomes addition of the exponents, and division becomes subtraction of the exponents. Another rule that comes up a lot is if we have a quantity, so it's a product. This doesn't apply to a sum or a difference, but if we have a quantity that's a product raised to a power, it's going to be each part of the product raised to the power. So it's going to be x to the a times y to the a. Another very related one is if we have a quantity that is a quotient raised to a power, then you get the numerator to the power and the denominator to the power. So again, these rules do not apply to a sum or a difference in parentheses, but they do apply to a product or a quotient. And we're going to use them a lot. And that's probably the main thing that people confuse, so make sure you don't confuse it. A fifth rule that we're going to use is what I call a power to a power. So we have x to the a, the whole thing raised to the b. So the parentheses there are really important. It's not x to the a to the b, it's x to the a, the quantity x to the a, raised to the b. And that you're going to multiply the exponents. A sixth rule is that x to the negative a is actually equivalent to 1 over x to the a. I always just remember if it has a negative exponent, it kind of like wants to be in a different part of the fraction. So if it's in the numerator with a negative exponent, it wants to be in the denominator with a positive exponent. And similarly, if it's in the denominator with a negative exponent, it really wants to be in the numerator with a positive exponent. So 1 over x to the negative a is the same as x to the a. These two rules are probably the weirdest rules, and they both actually come from rule number 2 here. But what you have to remember is that x to the 0 is equal to 1. So really, if you look at rule number 6 and you look at the right-hand side, we have 1, which is really x to the 0 over x to the a, so that's x to the 0 minus a, which is where the x to the negative a comes from. Okay, so those are the rules, and we're just going to use them a lot. So let's go ahead and do a bunch of examples. So the first couple that we do will be pretty straightforward. So here we have the same base, x, x, and x, raised to 3 different powers, and we're multiplying. So the rule says we just add up all of those exponents, so we're going to end up with x to the 11th. That's a straight application. This next example, we're going to have a little bit of a product in the numerator, and then overall this is a quotient. So the rules say when we are multiplying, we add the exponents, and then when we're dividing, we subtract. So it's going to be x to the 10 plus 15, and then minus 4, and then overall, that gives us x to the 21st. The next one is just an application of a power to a power. So power to a power, you want to multiply the exponents, and that gives us x to the 45th. This next example, we have a quotient to a power. So that's a very similar, it's really a power to a power, but then we have a quotient. So it's going to be x to the 3 times 6 and y to the 4 times 6. So each of the numerator and denominator gets that power, and then power to a power means multiply. So we have x to the 18th over y to the 24th. If we just have x to the negative 5th over y to the negative 7th, they're both kind of in the wrong place, you might say. So the x is going to drop down to the denominator with a positive 5 as its exponent, and the y is going to move up to the numerator with a positive 7 as its exponent. And here we have a combination of a bunch of things. So one way of doing this is it's a quotient to a power, so both the numerator and the denominator get that power. So that's going to give me to the negative third times x to the negative 3 times negative 4, and then x to the 5 times negative 4. And let me multiply those. So I have x to the 12 over x to the negative 20. So I'm dividing with the same base, so I'm going to subtract the exponents. 12 minus negative 20, and then finally that gives me x to the 32. But you could have done this in slightly different order. So if we go and we're going to do the same problem again, First, I'm going to deal with the quotient inside because it's the same base being divided, so I can actually just subtract the exponents. So that's going to give me this, which is x to the negative eighth to the negative fourth, power to a power. I multiply the exponents, and that gives me x to the third second. That looks a lot faster, and actually is a lot faster, so it might be the way you want to go. I'm going to come back in another video, and I'm going to do some slightly more difficult examples. So I hope you found this helpful so far, and good luck.